So our new unit on trigonometric functions, the very first thing we're going to do today is try and graph them. So a periodic function is a function whose values repeat at regular intervals, measured along the horizontal or independent axis. So we have looked at many different functions already. We've looked at linear functions, quadratic functions, exponential functions, and now just one last type of function we're going to look at are trigonometric functions. So learning about these functions is useful in science and economics. Events such as phases of the moon, the height of the tide at an ocean port, and the strength of an electric current feeding an appliance are examples of these functions. So trigonometric functions are also examples of periodic functions. When we're looking at this angle theta, what this is saying is that we have many different values for sine theta, but then they do start to repeat. As you make one full rotation, our values for sine theta would start to repeat again. So this is what's making this periodic. So just in this first lesson, the very first thing we're going to do is practice trying to graph these functions. So we're going to look at the sine function and the cosine function. We learned many different things in the last unit that are going to be useful again. So something that we saw before, we learned about the cast rule, where cosine is positive in this quadrant, all are positive in this one, sine positive here, tangent positive here. We also learned this other useful piece of information about associated angles. So if we're looking at the sine ratio, an associated second angle that we can find is 180 minus the first angle theta that we had. So this is going to be pretty useful right now. We also had special triangles that we looked at. So this is going to come back again as well. We had a chart previously for special triangles. The sine of 0 is 0. And if we're looking for exact values right now, the sine of 30 degrees was 1/2. The sine of 60 was root 3 over 2. And you might still have this table or know where to find it on the LMS. And the sine of 90 was 1. So those are some of the values that we've seen before. If we look at the decimal value, that's 0.00, 0.50, 0.87, and 1.00. So if I find the sine of 60, I get 0.87 on a calculator. And those are basically the values that we've seen before. Remember though, if we're looking at the sine ratio, when we look here, the second quadrant angles here will also be positive. So one way that we can find out, since our table in the last unit didn't go past 90 degrees, now what about 120 degrees? Well, 120 degrees is a second associated angle would be 180 minus 120. And these would give us the same value. So we would get 60 degrees. So if I'm using this property here for associated angles, I'm going to look at 60 degrees, and this is actually going to be the same as 60 degrees. So I have root 3 over 2, and I have 0.87. Remember that 120 degrees would be in this quadrant here, the second quadrant, and sine is still going to be positive in that quadrant. 150 degrees, we can do the same thing. We won't do this all the way down, but I can take 180 minus 150, and I get 30 degrees. So an associated angle with 150 degrees would be 30 degrees. When I look here, that's 1/2, so this is going to have the same value, and that's 0.50. So basically what we're doing is just trying to fill in a table of values that we can graph this function. 180 degrees, when we look at 180 degrees, an associated angle would be, that was 0, because 180 minus 180 would be 0. So an associated angle would give us the same value as 0 degrees. Now we're moving up to 210 degrees. So if I'm trying to find, you can just type in sine 210 and we can get these decimal values. I'm just trying to point out that 210 is now down in this quadrant here, in quadrant 3. and our sine values in quadrant 3 are going to be negative. So 210, for example, if I do 180 minus 210, is negative 30. So this value is going to be associated with our 30 degrees, but it's going to be negative. So this would be negative a half as an exact value, or we could do negative 0.50 here. 240, an associated angle with 240. If I did 180 minus 240, I get negative 60. So for here, we're going to have an associated value with 60 degrees, which is root 3 over 2, but it's going to be negative. And if I just type sine 240 on my calculator, I should get negative 0.87. 270, if we just continue on the same way, 180 minus 270 is negative 90. So if I look at 90 degrees, I'm going to have the same value, but it will be negative. 300, I can type sine 300, and I'd get negative 0.87. But if I want to use 180 minus 300, 180 minus 300 is negative 120. And 120 degrees we already know is root 3 over 2. So this would just be negative root 3 over 2. And then 330, same thing. If I do 180 minus 330, I get negative 150. So we already figured out 150 was 1/2. So this would just be negative 1/2. And 360, 180 minus 360 is negative 180. And 180 was 0, so this is still going to be 0. So what we've done is just created a table of values from 0 degrees up to 360 degrees. It could go, we could go into the negative angle measurements here and continue on. And as well, we could go past 360. So this function is going to go on and on in both directions. These are just some of the values that we've chosen to be able to graph the function. So down here, what I have is a different kind of Cartesian plane, really. It changes when we have angle measurement on the x-axis. So this is our angle measurement, theta, and then we still have the same y-axis. Sometimes you just want to make sure that whatever you're going to graph will fit on the graph paper that you have. So I have room to space out. If that's 1 and this is negative 1, that's going to work just fine. So when we had the table up here, when we found sine of 0, it was 0. So this would be a point on our graph. When we went to 30 degrees, the sine of 30 degrees was 0.5. So since these are broken up, this is a typical way to break it up into 30, 60, 90. So if this is 30, and this is 60, 90, this would be the 120, and this would be 150. We have 210, 240, 270, and then 300, and then 330. So what you see here, the 90 is the perpendicular, 90, 180, 270, 360. This is our 90 degree angle, and then 180, and then 270, and then 360 would be one full rotation. So I'm going to put these values in down below. What I see is when we had 30 degrees, that was 1/2. So I'm going to go right here. 60 degrees was 0.87, so somewhere up there. 90 degrees was 1. 120 was also 0.87. 150 degrees was 0.5. 180 was 0. 210 was negative 0.5. We had negative 0.87, negative 1, negative 0.87, negative 0.5, and then back to 360 degrees. So what we try and do is just sort of trace a nice smooth curve here, and we know that it goes on in both directions. And so this is the sine function. It starts at 0, 0. The really important parts are that at 90 degrees we hit 1. At 180 degrees we're back at 0. And then this function goes down to -1 at 270 and back to 360. So eventually we might not have to plot as many points. We're just trying to get the idea of what this looks like. So this would be one period. That's why this is a periodic function. We have one cycle when we get back to where we started at 0.